Cosmic map reveals a not-so-lumpy universe. Cosmologists have produced the biggest map yet of the universe's structure, and they find it less lumpy than previous surveys have suggested. The new results, part of the ongoing Dark Energy Survey, DES, charted the distribution of matter in part by measuring the way that mass bends light, an effect known as gravitational lensing. The universe was extremely smooth, with matter evenly distributed in its infancy nearly 14 billion years ago, but mass has been clumping together ever since into galaxies, gas clouds and other structures. Data released by the DES team on August 3 suggest that the clumping has happened more slowly than indicated by earlier estimates, which were based on baby pictures of the universe made by measuring the cosmic microwave background, the afterglow of the Big Bang. The difference in the results produced by the two techniques is still within the margins of error in both sets of measurements, say the survey leaders. A smaller gravitational lensing survey, the Kilo-degree survey, KDS, also found a similar discrepancy last year. Either way, the results show that DES is now reaching levels of precision that make it competitive with microwave background surveys, including those by the European Space Agency's Planck satellite, says survey leader Joshua Freeman, a cosmologist at the Fermi National Accelerator Laboratory in Batavia, Illinois. We believe that, with these results, we're no longer the poor cousin to other efforts, he says. We now have results that have comparable power to constrained cosmology. DES, a collaboration of more than 400 researchers, employs the still-young technique of weak gravitational lensing using the 4-meter Blanco telescope, part of the Cerro Tololo Inter-American Observatory in Chile. According to Albert Einstein's general theory of relativity, mass warps space, so a large amount of matter in the foreground of a galaxy can bend its light in a way that makes it look slightly squashed. This is true whether the foreground mass is made of invisible dark matter or ordinary matter. Galaxies can often appear oblong for other reasons, including their actual shapes and orientation, but if many galaxies in a certain region of the sky appear on average to be skewed along the same direction, gravitational lensing is the likely culprit. The latest study was based on the first year of data collection, in which DES mapped 26 million galaxies in the southern sky and measured their apparent shapes. The team then calculated the amount of gravitational lensing in each part of the sky to reconstruct the density of matter. The results confirm what has become the standard model of cosmology, in which ordinary matter constitutes only 4% of the universe's contents. But the researchers find a slightly smaller amount of dark matter, about 26%, than Planck's 29%, with the rest being taken up by dark energy, the stuff believed to be pushing the cosmos apart at an accelerating speed. Galaxies and dark matter are not spread uniformly across the universe, and instead have been concentrating, under the pull of gravity, into a web-like structure of clusters and filaments, with enormous voids in between. The level of concentration measured by DES is 7% lower than what the standard model of cosmology predicts, based on Planck's data from the primordial universe. If confirmed, this gap could mean that mass has been clumping at a lower pace than predicted, potentially revealing new physics. For example, it could point to unexpected interactions between dark matter and dark energy, or to new types of neutrinos. The discrepancy between the standard cosmological model and the newer clumping measurements is not statistically large, at 1 standard deviation, although the KDS survey last year found the two values to be 3 standard deviations apart. The DES results, which have not yet been peer-reviewed, were presented at a meeting of the American Physical Society at Fermilab on August 3, and the authors posted a battery of 10 papers online. Although cosmological observations have in recent decades been converging towards a consistent picture, the clumpiness observations are not the only type that have troubled researchers. In particular, astronomers have measured the current cosmic expansion to be faster than would be predicted based on Planck data. George F. Stathio, the director of the Kavli Institute for Cosmology in Cambridge, UK, and a member of both the Planck and DES collaborations, says that the discrepancy found by Day is troubling and potentially more worrisome than the one relating to cosmic expansion. But cosmologist Anthony Tyson, a pioneer of weak gravitational lensing at the University of California, Davis, says that he expects that when Day accumulates more data, its findings will draw closer to the Planck results. I believe they have been very careful and conservative in their interpretations, he says of the survey. Overall, researchers are excited to have an additional tool to probe the cosmos in ever greater detail. My own view of all of these measurements is that they are stunning tests of the cosmological model, and the precision and accuracy only keep getting better and better, says astronomer Wendy Friedman of the University of Chicago. The latest map is based on Day's first round of observation, which began in 2013, and it covers about 1/30th of the full sky, 3 times larger than a preliminary map the survey released in 2015. The final survey, due to conclude in 2018, will cover 1/10 of the sky. The results might appear sometime in 2020, Freeman says. Ultimately, the goal of the day is to map a large enough region to see how the influence of dark energy has evolved over the universe's recent history.